Let's consider the mass spectrum of 1-bromopropane. In 1-bromopropane, we have one bromine atom, but in bromine atoms, we have two isotopes, isotope 79 and bromine 81. Okay, so in the mass spectrum of 1-bromopropane, we can see that there are two molecular ion peaks. Okay, one is the M plus ion, one is the M plus 2 ion. That means the two molecular ion peaks are the M plus peak and the M plus 2 peak, and these are almost of equal heights. That is 1 is to 1. Okay, if we see the isotopic abundance of these atoms, in bromine we have bromine 79 50.5 and bromine 81 49.5. Okay, and it's like roughly 50-50, whereas in the case of chlorine we have chlorine 35 75.5 and chlorine 37 24.5, almost 75 is to 25. Okay, so these are the two prominent isotopes which we come across in the mass spectrometry. Other elements, the isotopic abundance of the isotopes are not so high. So like in the case of carbon, we have the carbon 13 in 1.1%. In the case of nitrogen, 0.4%. In the case of oxygen, 0.2%. In the case of sulfur, 0.7%. So always in the mass spectrum, you will always find that after the molecular ion peak, you have a small peak. Okay, sometimes it is bigger, sometimes it's just like a dot. Okay, so those are the isotopes of the elements which are present. Say when there are many oxygen atoms in the molecule, that means the isotopic peak due to oxygen will appear as a very small peak. Okay, and when you have many carbons, that means the isotopic abundance of carbon is more, so you'll have a bigger peak. Okay, but in the case of the two halogens, that is chlorine and bromine, you have very prominent isotopic peaks. Okay, that is due to the presence of the isotopes in higher percentage. In the case of chlorine, it's 75.5 is to 24.5. That means 75 is to 25%. In the case of bromine, it's almost 50-50. 50.5 for the bromine 79 and 49.5 for the bromine 81. Now again, coming back to the mass spectrum of 1-bromopropane. So the M plus peak 122 and the M plus 2 peak 124, and you see that they are almost of equal heights. So these kind of peaks will always give you the hint that it could be the bromo containing compound. Okay, and you can see also that there will be a similar kind of peaks. Okay, similar kind of peaks, that is when you have considered the two isotopes. So here the isotopes which have been fragmented, these also appear in the mass spectrum. So 79 and 81. Okay, and to see the fragmentation, okay, you have to consider the difference from the M plus peak to the base peak. Okay, so the M plus peak is 122. So 122 minus 43. Okay, that gives you the loss of a fragment of M by Z 79. Okay, the loss of a fragment of mass 79, or from 124 to 43. 124 minus 43, that gives you a difference of 81. So that is the fragment which is of the isotope 81 bromine. Okay, 43 is nothing, it's the propyl cation, CH3 CH2 CH2 plus. For carbon, we have 3 carbons, so 36, and you have 7 hydrogens, so 43. So that is the fragment due to a propyl cation. Okay, you can also see there are also other fragments, but those are not prominent, which are due to the different cleavage of the alkyl chain. Okay, but the importance of the M plus and the M plus 2, that will give you the hint that it is a bromine containing compound. So in this compound, okay, ethyl bromide. Ethyl bromide, here also you have the bromine isotope. You have two isotopes, one is 79 bromine, one is 81 bromine. So when you take 79 bromine, you are getting the M plus peak. When you take bromine 81, you are getting the M plus 2 peak. Okay, and you can find out the fragmentation by subtracting. Say like here you have for the alkyl chain you have 29, and then for bromine, if it's bromine 79, then you have 8, then you have 108 as a molecular ion peak. That is, this is your M plus. And then for the M plus 2, you have 29 plus 81. So you have 110. This is your M plus 2 peak. Okay. So this peak is the base peak at 29. Then also you have the other peaks, okay, which can be the fragmentation due to the carbon-carbon cleavage. Okay, but as I've said, the importance of the M plus and the M plus 2, that gives you the hint that it is a bromine containing compound, and it is a mono bromine substituted compound. Now let's consider another example. Here you have a bromobenzene also, you will have 2 M plus and M plus 2 peaks in the molecular ion peak region. So as you can see here, the mass 156 is due to the bromine 79, and the mass 158 is due to the bromine 81, and these are of equal heights in the ratio of 1:1. Now here is a dibromo compound. Okay, here is a bromine molecule. In the case of a bromine molecule, you have two bromine atoms. So you have the 3 molecular ion peaks. You have the 3 molecular ion peaks, which is due to the different combinations. So you can have a combination of a bromine 79 and bromine 79. Okay, then you can have a combination of bromine 79 and bromine 81, and then you can have also a combination of bromine 81 and bromine 81. So this combination will give you the molecular ion peak at 158, that is the M plus. Okay, then bromine 79 and 81, that gives you a molecular ion peak at 160, which is the M plus 2. And then you have bromine 81 and bromine 81 to give you a molecular ion peak at 162, which is the M plus 4. So in such cases, in such spectra, when you have 3 molecular ion peaks of this nature of this nature of peaks, okay, as you can see here, the difference, see this peak, which is the M plus 2 peak, it's double the heights of the other peaks. Okay, because here the probability of having the bromine 79 and bromine 81, that is more, or we can say double that of the case where you have bromine 79 and bromine 79, or bromine 81 and bromine 81. So this height is double the heights of the other peaks, that is double the height of the m plus and double the height of the m plus 4. So dibromo compounds are in compounds containing more than one bromine atom. You can have a set of peaks as shown here, and the nature of the peaks will be then the middle peak or the m plus 2 peak will be double the height of the m plus and the m plus 4 peak. Here you have a mono bromo compound, that's you have the two peaks m plus and the m plus 2. You can find out the structure of this compound. Okay, find out the structure. What is the alkyl group? Okay, here you can see the mass 115. Okay, 115 for this m plus 2. Okay, so 113 for the m plus peak. Okay, so you can find out the uh, structure of the compound from the given spectrum. In this case, this is the mass spectrum of a 1,3-dibromo compound. 1,3-dibromo compound, CH2, CH2, CH2. Then here you have Br, here you have Br. Okay, so these two bromine atoms, you can have a different combination. You can have 79, 79, or you can have 79 and 81, 79 and 81, or you can have 81 and 81. Okay, so you have again a set of molecular ion peaks. Okay, m plus, m plus 2 and m plus 4, and just like I've shown before that the heights in this nature, that the middle peak, that is the m plus 2 peak, is double the height of the m plus or double the height of the m plus 4. Okay, that is because of the probability of getting the bromine 79 and bromine 81, that is double that of the possibility of having the bromine 79 79 or bromine 81 81. So when you get this nature of peaks, you can easily conclude that it is a dibromo compound. Okay, then you can also predict the fragmentation. Okay, so from one, sorry, here it's from 200, 202, 204. Okay, 200, 202 and 204. Okay, from here to here you can find out what is the fragment which has been lost, and from here to here you can find out which is the fragment which has been lost. Okay, so if you remove the two bromine atoms, if you remove the two bromine atoms, you are left with the propyl chain, CH2, CH2, CH2. Okay, so 3 carbons, 36, then 2, 2, 2, 6, so 42. Okay, so 42 is the mass of this fragment, and you can do the calculation from m plus, okay, to this peak, or from m plus 2 to this peak, or from m plus 4 to this peak. Okay, next let's see the mass spectrum of a chlorine containing compound. Okay, here you have one chlorine atom, and in chlorine containing compounds, you have the possibility of having the combination of chlorine 35 and chlorine 37. Okay, so when we take chlorine 35 into calculation, you have the mass of 62. Okay, so that will be your M plus. And when we take the chlorine 37 into calculation, then you have the M plus 2. Okay, you have a mass of 64. Okay, so the ratio that means the height of these peaks will be not same as in the case of the bromine containing compounds, but here the M plus 2 peak is one third than of the M plus peak. That is because of the isotopic abundance difference. In the case of chlorine 35, the isotopic abundance is 75, and the case of chlorine 37, it's roughly 25%. So it's a one third that of the M plus peak. Okay, so here also you can calculate the fragment which is being lost. So from 62 to 27, okay, or from 64 to 27, you can see the difference that the main fragmentation will be the cleavage of the CCl bond. Now, in the case of the case of a dichloro compound, in the case of dichloro compound, you'll have a set of peaks in the molecular ion peak region. Okay, and these are of different heights, not as simple as in the case of a monochloro compound, but in dichloro compound, the calculation is based on the mathematical derivation, which always gives you the ratio of 9 is to 6 is to 1. That means the m plus peak in the case of this dichlorobenzene here, the molecular weight is 146. Okay, so the M plus peak is 146, the M plus 2 peak is 148, and the M plus 4 peak is 150. Okay, and the probability of having the combination of chlorine 35, chlorine 35, then the next probability is chlorine 35 and chlorine 37, and chlorine 37 and chlorine 35. It's almost same. Okay, so these two will be giving you the M plus 2 peaks. Okay, and then you have also the probability of having the combination of chlorine 37 and chlorine 37 to give you the M plus 4 peak. Okay, and the nature of the peaks, the ratio of the heights of these peaks will be 9 is to 6 is to 1 according to the calculation by this mathematical formula, that is AB whole thing square, which is equal to A square plus 2AB plus B square, where A is equal to 3 and B is equal to 1. That is the ratio which is shown here in the nature of the M plus peaks, or the molecular ion peaks. So you can see here the dichloromethane. In the case of dichloromethane, you have a set of the molecular ion peaks. Okay, 84 is the M plus peak, 86 is the M plus 2, and 88 is the M plus 4 peaks. So these kind of peaks will suggest that it is a dichloro compound. And what type of dichloro compound and how long is the alkyl chain, that you have to find out by the calculation. You subtract from the molecular ion peak, you subtract the fragment which is lost when you consider the base peak, or when you consider the other peaks which are shown in the mass spectrum. Okay, say from from 84 to 51. Okay, what is the fragment which has been lost? 84 minus 51. Okay, so you can see that it is 33, but you don't have a fragment 33. It's not it. So that means then, or you can take the calculation by subtracting. You know now the isotopes. So 84 minus 35. Okay, 84 minus 35, that means the most abundant isotope is 35. So if you subtract 84 minus 35, you are getting a peak, or you're getting a fragment with the mass 49. Okay, with mass 49. So that is the base peak. So from 84 to 49, it is the M plus peak. And the M plus peak, how you have got the M plus peak? The M plus peak has been obtained by taking the isotope 35 into calculation. It's not it. So when that fragment is lost, when this chlorine 35 is lost, you are getting the base peak of 39. Okay, so so uh, like that you can calculate. Okay, you can calculate the fragment, the next fragment which is lost. Okay, you can from here you can remove, okay, another you can remove another fragment, or you can have other peaks. Okay, say when you remove from 86, from 86, when you remove chlorine 35, 86 minus 35, so you have a peak of at 51. So this is the peak at 51. So the peak at 51 will be then this this molecular ion peak 86 has knocked out a chlorine 35. Okay, that means another chlorine will be there, but not the chlorine 35. Like that, a chlorine or a molecular ion peak of 88. Okay, 88 minus 35. Okay, 88 minus 35. But that calculation, the calculation which according to the formula given by the mathematical formula here, that has to be taken into consideration. Okay. And in the case of iodine, okay, in the case of iodine, you don't have the isotope. Okay, you don't have the isotope, so you will get only one molecular ion peak. Okay, you'll get only one molecular ion peak. But always in the case of an iodo compound, the huge gap between the molecular ion peak and the next peak, okay, between the molecular ion peak and the next peak, that always give you the indication that it is a chlorine containing compound. Okay, it's a chlorine containing. In the case of iodine containing compound, like because iodine, it has a mass of 127, so this huge gap, that means from the molecular ion peak, from the M plus to the next peak, this gap. Okay, so if you have this gap, that means you can easily predict that it is an iodine containing compound. Okay, so that way you can predict the presence of the elements. Okay, that means the presence of halogens in the given unknown compound. Okay, so for this compound, for this spectrum, you can just find out the uh, mass, you can find out the molecular weight, you can find out the fragmentation of the compound. Okay.